Now I told you about the rate of reaction. So what is the formula to calculate the rate of reaction? That also I have discussed with you. That is change in concentration by change in time. We can say that final concentration minus initial concentration divided by final minus initial time. We can say that in this way. Now we are having different types of rate depending upon the type of reactions. We are having average rate of reaction. Average rate. What do you mean by average rate? Average rate of reaction means a change in concentration of any of the reactant or product species in a given unit time for a specified interval of time. You can say that. You can repeat. That is the change in concentration of any of the reactant or the product species per unit time in a specified period of time. Got it? In a particular period of time, in a specified period of time is known as the average rate of reaction. Got it? Now one more rate is there, instantaneous rate of reaction. So what you will say? Same definition, just will change one or two words. What is that? That is the change in concentration of the reactant or the product species per unit time in a given instant of time. Here I said in a specified period of time. It will be in a given instant of time. For a particular instant of time, we can say that. That is a change of concentration of the reactant or the product species per unit time for a given instant of time, or for a particular instant of time is known as the instantaneous reaction. We can say that. That is instantaneous rate of reaction, not instantaneous reaction, instantaneous rate of reaction, we can say that. Now see, the symbol are also being different. For the average rate of reaction, we use it like R. Let us say R average. We can say that. You can write AVG also, or simply R also it can be written. So here we use the word delta. Alright, like delta A by delta T. We can say that. But same thing for instantaneous reaction, instantaneous rate of reaction. Instead of delta, we will be using del A by del T. We can say that. Clear? We can use it del A by del T in this way. Okay. So this is what you can say. This particular one, that is instantaneous reaction, we use our del means a small change. We can say that. Yeah. When the rate of reaction is calculated instantly, then there will be a small time and there will be a small change in concentration only. But for an average, definitely compared to instantaneous, the average rate of reaction is much more bigger. We can say that. Because the time interval is also bigger and the change of concentration is also compared to instantaneous reaction is quite bigger. We can say that. Clear? So in this way, average rate of reaction you understood and instantaneous rate of reaction you understood. Both are nothing but change in concentration by change in time. The thing is that this is for the specified period of time and this is for instantaneous period of time. That's the difference. That's nothing else. Now, next. After that we'll come to, that is suppose if a reaction is given, then how will you calculate the rate of reaction? How, if a reaction is given. Now one thing, remember it, that while calculating the rate of reaction, remember one thing, that there is a decrease in concentration of the reactant and there is increase in the concentration of the product. You've seen the graph. Because in case of reactant, because what I said, the reactant species consumed, so concentration of the reactant is going to decrease and the product species formed. Got it? So the concentration of product species is increased. Got it? Always the reactants disappear and the product appear. Got it? So hence always remember it, in case of reactants the concentration is always decreasing. The product, if the reactant is decreasing. Got it? But in case of the product, the concentration of product is increasing because product is appearing. If the reactant is disappearing, the product is appearing. That's it. So this is the basic thing you have to remember it. Now let us take one example. PCl5 gives PCl3 plus Cl2. Let us. PCl5 gives PCl3 plus Cl2. Now I need to calculate the rate of reaction from this. So R is equal to, what will I write? Minus, that is, I can write D also. Instead of delta, I can write D also. That is D concentration of PCl5. You know concentration is represented by square bracket, you know that, by dt is equal to D concentration of PCl3 by dt is equal to D concentration of Cl2 by dt. Now here this PCl5 means it is change in concentration of PCl5. Here it is change in concentration of PCl3 and change in concentration of Cl2, and dt you know the small change in time. Correct. Now the question is here, why did I do minus here? Why I put a minus sign and here the plus sign? Now listen carefully. So here when you calculate the change in concentration of PCl5, so you know that when we'll start a reaction, initially this is the concentration and this is your time, isn't it? So PCl5 is a reactant, so concentration is going to decrease. So initial concentration is somewhere here and this is your final concentration, let us say. So definitely initial minus final, when I will do, it will be minus. Because it is bigger minus smaller, na? It will be minus. But rate cannot be negative. Rate is always positive. So to convert into positive, I put a minus sign before the change in concentration. Got it now? Again I repeat. In case of reactant, now this is for the reactant, the concentration is decreasing, you know that. So initial concentration is this and this is your final concentration, let us say. So initial minus final, when you will do, then what will happen? It is less, this is more minus less, the answer will be negative. This will be negative. Now if I put a negative sign before, negative or negative means what? Positive. Why do I convert it into positive? Because rate cannot be negative. Rate is always positive. It is absurd. It is meaningless to say the rate is negative. What is negative? Rate of a reaction can be 0. At the least, what you can say, at the last, it is possible that minimum the reaction is taking place. Minimum may not 0. The reaction is not taking place. But it cannot be negative, isn't it? It cannot be negative. It is absurd to say that. So hence, to convert it into positive, we do this particular thing. That is minus sign we put it. Got it now? And minus sign here, it indicates that this is for the reactant and this is for the product. Because in the product, we don't need to put the minus sign. Because product is increasing. Initial always is 0. Final is always greater. So final minus initial, when I do, the answer will be what? Always positive. So no need to make it here, but you can say a negative or any positive sign. Because it's always this is positive. Got it now? It's fine. So in this way, if a reaction is given, we calculate the rate of reaction in this way. That is, individually, we calculate it. Now, why it is equal to, why the rate are equal? That's it what I am saying. Alright, that's it what I am saying. Because, see here. Now, let us say in maths you have done this particular thing. Okay, in maths you have done it. Achha, let me give another example and let me explain you. That is better. Let me take a general reaction and explain you. That is better. General reaction. It will be better for you to understand. XA plus YB gives ZC plus WB. We are having reactants A and B and products C and D. And number of moles of reactant is X and Y. Number of moles of product is Z and W. Now R is equal to what it will be? Minus 1 by X D concentration of A by dt is equal to minus 1 by Y D concentration of B by dt is equal to 1 by Z D concentration of C by dt is equal to 1 by W D concentration of D by dt. Now why we did 1 by X, 1 by Y, 1 by Z, 1 by W? Means we have taken the reciprocal of the number of moles. Why we did it? Why we took the reciprocal? Listen carefully. Now suppose if I ask you that A does a work in 10 days. So A's 1 day work is how much? 1 by 10. B does the same work in 5 days. So B's 1 day work is how much? 1 by 5. Remember, same work. Alright, fine. C does a work in 12 days. So C's 1 day work is how much? 1 by 12. So 1 day work for everybody is the same. Yes, 1 by 10, 1 by 5, 1 by 12. Here also same thing. Here it is for the X moles of A. Now here when I am calculating the rate, I am calculating for how many moles? 1 mole. So it is 1 by X. Hence it is 1 by Y. This is 1 by Z. This is 1 by W. And the rate of reaction for the 1 mole is same. So in case of PCl5 in the previous reaction, what do you find? The rate of reaction is calculated for 1 mole. Because PCl5 give PCl3 plus Cl2. How many moles was there? All 1 mole. So hence the rate is equal. So for that reason I took different number of moles here. So when I took different number of moles, what I did to convert into 1 moles, what will I do? I will calculate the reciprocal. So hence I have calculated the reciprocal of moles. So when I calculate the reciprocal, the rate is the same for 1 mole. As I said, the 1 day's work is same. You have read in maths in unitary method this particular one. And I have explained you why it is minus. Because the concentration of the reactant is decreasing. But the rate cannot be negative. Rate is always positive. So hence I I multiply a minus sign before. Hence I multiply a minus sign before, we can say. Clear now? Because here the rate is calculated for 1 mole. So hence the reciprocal is being done. And why I put minus sign, that also you understood. Clear? So in this way we calculate the rate of reaction when the equation is given to you. When the equation is given, then this is the formula it is used. When the equation is given. But suppose the value is given, the final is this, initial is this, the time, initial time is this, final time is this, then which formula will you use? You will be using the formula change in concentration by change in time. Or suppose the atmospheric pressure I am saying, the partial pressure is given. Then what you will do is that you will subtract the change in pressure by change in time and you will be doing it. So according to the question you are going to use the formula. That's it, according to the question. Now one more thing is left, that suppose if the graph is given, how will I calculate the rate of reaction from the graph? Because the different methods I said, that if it is given what you can say the values, then numerically you will be doing it. If it is given the equations, then you will be calculating in this way, whether it is average rate or instantaneous rate. The sign only is the symbol only is different, but the concept is the same change in concentration by change in time. Alright, now suppose the graph is given to you, this sort of graph. Let us say the concentration is given and time is given, and this sort of graph is given to you, this sort of, let us say. Now I will be asking you that you tell me what is the change in, calculate the rate of reaction between 5th second and 15th second. What is the rate of reaction between this? So what you need to do is that you will drop a straight line here. Clear? Then after that you will be drawing a tangent. You know that. You read in physics. You will draw a tangent. Isn't it? Now you see that this particular, that within this interval where the tangent meets, what is the concentration of that particular, what you can say, this tangent where it meets. Are you following what I am saying you? Now this particular final concentration is this, and what is the initial concentration? After drawing the tangent, what you find is that it meets here somewhere. Alright, it meets here somewhere. So this is your initial, this is your final for the reactant. So final minus initial you will do, put a minus sign in between before that. So that will give you the change in concentration, and this is your change in time. It is 15 minus 5, it is 10. Alright, again I repeat, this graph is given, you need to draw a tangent first. Alright, then you will see where the tangent cuts the graph. You have read all these things in physics, it's nothing new. So it cuts here. So this is your initial, and here this, what you can say, this is your final. So final minus initial you will do, definitely here the answer will be negative. So what I said, if it comes negative, you have to multiply a negative sign before. Negative or negative will make positive. So that is a change in concentration, this is a change in time. That will give you the rate of the reaction. So if the graph is given, then you need to calculate the graph in this particular way. Suppose you will say, sir, the graph is in this way. No problem, you will draw the tangent in this way. This is a tangent. You see, here you can say that. Let us say this, it meets here, this one, this point, and let us say it meets here, this point, or any. It depends upon the time interval. According to the time interval, suppose the time interval is 20 and this is time interval is 0. So between 0 and 20, if the product it is asked, you will do it accordingly. You will draw the graph. Then after that you will draw a tangent, and from there you will know you have to draw a straight line and you have to do it. Of course we will do the numericals, at that time you will come to know. So in this way, if the graph is given, then you need to draw a tangent, and you will see where it cuts the graph in the y-axis and the x-axis. And you will be finding it out the change in concentration and the change in time, and accordingly you will put the value and you will get the rate of reactions from the graph. So I said you 3 methods to calculate the concentration, the change in concentration by change in time. But we can do it by the use of formula, we can do it by the help of equations, that formula also I said you. We can also calculate graphically, that also I said you. Thank you very much.